Today we're covering the average rate of change in functions. When you are doing the average rate of change in a function, we are being specific and only covering certain intervals in our set. So this is very commonly known as the slope of a formula. So if you think back to whenever you learned about slope, that can be the change in y over the change in x, otherwise known as y2 minus y1 over x2 minus x1. Super important thing to notice in this formula is that the 2's always come first and the 1's always come second. You could switch them around and you could say y1 minus y2 over x1 minus x2. You'll get the same number, but your interpretation might be a little bit off. The thing to notice is, again, even though I've switched it up, the 1's are in line with the 1's and the 2's are in line with the 2's. So to find the average rate of change of a function on this interval, 0 to 2, what we need to do is evaluate the function at 0 and at 2. So for f of 0, remember we're replacing all x's with 0. So everywhere that I see an x, I'm now going to write 0. So I get 2 times 0 squared minus 3 times 0 plus 1. Then I'm going to use my calculator or do this in your head because 0 squared is 0, 0 times 2 is 0, 3 times 0 is 0, and then plus 1. 0 minus 0 plus 1 equals 1. So that coordinate point, if we were to graph it, would be the x value is 0, where the y value is 1. Now we'll do the same thing for f of 2. So again, I'm going to put 2 everywhere there's an x. So it becomes 2 times 2 squared minus 3 times 2 plus 1. Please be careful, you have to follow correct order of operations. You do the 2 squared first. Okay, you are not allowed to do 2 times 2 and then square it. You'll get a wrong answer every time. So 2 times 4 is 8, 3 times 2 is 6, plus 1. 8 minus 2 is 2, and 2 plus 1 is 3. So my coordinate point here would be 2, 3. Once we have our coordinate points, or that we've evaluated the function, the next step is to actually find the slope of the given points. So slope is your rise over your run, otherwise known as your change in y over the change in x. And those little triangles are the Greek letter delta, which just means change. And then you have your y2 minus y1 over x2 minus x1. And you don't have to write that every time. I'm just trying to recall all of the different ways that your previous teachers may have shown you this. So then what I'm going to take is I'm going to take the y value from the second equation. So I'm going to use some colors here to help us out. I'm going to take the y value, which is the second one. So this 3 becomes y2. Then y1 comes from the first problem. And then x2 comes from the second one. And x1 comes from the first one. Once you have that, you have to simplify each set. So 3 minus 1 gives me 2. 2 minus 0 gives me 2. 2 divided by 2 is 1. So the average rate of change for f of x on the interval 0 minus 2 is 1. Now you can do this from just functions like I just showed you there, or you can do it from a table. So here's an example of a table. We are comparing per capita consumption of hot and cold cereals based off of the year. And we are specifically looking for the average rate of change from 1992 to 1995. So if a couple things to look at here, it says years since 1990. So if this is 0 here, that means that this is 1990. This 1 represents 1 year after 1990. So this column represents 1991, 1992, 1993. That might be a help for some of you with reading your table. And then this says per consumption in pounds. So in 1990, the average person consumed 15.4 pounds of cereal. Okay, that's 15 pounds of Fruit Loops. Okay, that's a lot. So the year 1992 is represented by which column? This is just making sure that you know how to read the table. So 1992, we've already labeled it, would be this column here. Okay, in 1995, it's represented in the 5th column. So write those 2 years as coordinate points because we're going to need those coordinate points in order to do our equation for rate of change. So the first one for 1992 would be 2, 16.6. And then this one here would be 5, 17.1. And then to find the rate of change, we take the y values and subtract them. So subtract the y values and then subtract the x values. So my y values, now watch what happens. I'm going to do this both ways so that people can see what happens if I switch them. So as long as I stay consistent and I go 1 to 2 and 1 to 2, okay, or let's switch it around. If I go 17.1 minus 16.6 and then switch the bottom 2, let's see what happens. So if I do that, I get 16.6 minus 17.1 and I get negative 1/2. And then 2 minus 5 gives me negative 3. If I put that in my calculator, that simplifies to 1/6. Over here, if I do 17.1 minus 16.6, I'm going to get positive 0.5, and then on the bottom I'm going to get positive 3. So I'm still going to end up with 1/6. So whether you do the first or second point first is not important. The important thing is these two both come from the first set, and these two both come from the second set. So my average rate of change is 1/6. So if we were to interpret that, what does that mean? That means that we are increasing our cereal consumption by 1/6 every year. Okay. We can also do this from graphs. You want to read carefully the graph so that you know what it's talking about. So Joe is visiting the Eiffel Tower in Paris. He accidentally drops his camera. So that makes sense why the graph is going down, because he dropped something. Use the graph to estimate the average rate of change for the camera's height at 4 seconds to 7 seconds. So notice that your x-axis is in seconds. So the first one I'm looking for is at 4 seconds. So I have to go up here and it says estimate. It's not perfect, but we have to know what that coordinate point is. So when we're doing that, we know that our x value is going to be 4. But how do we figure out our y value? So if we come over here, we know that this one's 600 and it's 1 above 600. So what we need to do is go down here and we say, okay, so here's 3 points to get to 150. So 150 divided by 3 tells me that one section is worth 50 feet. So if this is 600, one above that would be 650 feet. So at 7 seconds, we're going to go over here to 7. So this is 6, so there's 7. So this point here would be 7 and then 100. So the average rate of change, we take the y values of 650 and 100 and subtract them. Then we take the x values and subtract them, 4 minus 7. So 550 divided by negative 3. That's going to give me negative 183 1/3. Now, what does it mean when your rate of change is negative? It means that something's dropping, it's going down. So when you're interpreting the answer, and on Math Excel, it's going to ask you to interpret everything. So you want to make sure that you understand what it means. So that negative 183.3 repeating means that the camera is dropping 183 1/3 feet every second until it hits the ground. So I don't have to put the negative in the sentence because I'm using the word drop to acknowledge the negative direction. Number 2 is super similar. What I want you to do right now is pause the video and I want you to try number 2 on your own. Now let's check your work. So if you did this one, you are finding from the years since 1999. So that means that 0 is 1999. This means is 2000, 2001, 2002, 2003, 2004, 2005. So even though they're not labeled those specific years, I'm actually looking for this point here. And again, it's an estimate, so it's not like 100% perfect, but we can get pretty close, which is 2 and 8,000. And then the 6 is going to be 6 and 3,600. So how did I get 8,000, you might be wondering. I used this 16,000 and I noticed there's 1, 2, 3, 4 gaps. So 16,000 divided by 4 means that each level is worth 4,000. So your rate of change, you've got 36,000 minus 8,000 divided by 6 minus 4. You end up with 28,000 divided by 4, which is 7,000. So interpret that. What does it mean? It means the net sales, so $7,000 per year since 1999. Okay, your last section of notes is just interpreting the function. This is just like the example that we did at the very beginning. I'm going to do one with you, and then you are going to pause the video, do the rest on your own, and then come back and check your work. So number 1 here, just as a recall, you're going to evaluate each function at each number. So you're going to say f of 1, 3 times 1 plus 2, because I'm replacing the 1 with x. We get 3 plus 2, which is 5. And then f of 4, which is 3 times 4 plus 2, is 12 plus 2, which equals 14. Once you've found those values, you have your coordinate point 1, 5, because I'm taking the 1 here and the 5 from here. And then your second point is 4, 14. Once you have those 2 points, you're subtracting the y values, subtracting the x values. So y values, subtract them, 14 minus 5. And then your x values, subtract them, 4 minus 1. You end up with 9/3. So your rate of change is 3. Like I said before, pause the video now, do your work on your own, and then I'm going to write your final answers so that you can check your work. If you're now checking your work and you did not get these answers, this would be a great thing to go to the help session Google form, fill it out and say, Ms. Smith, I need help with finding the average rate of change from a function with an interval. Okay, now you're going to log on to Math Excel and do your practice problems. Good job today.